Grigg, hosting the Unseen Podcast, episode 57. I'm here in Australia, and the date here is the 20th of August, but I believe in the rest of the world, most of the rest of the world, it's the 19th of August. Now we're going to talk about the future of humanity, and with me I have two guests. I have Chris Prophet.
Hi.
And I have Patrick Festa.
Hello.
So it's a pretty broad topic, but I'm just trying to think about where humanity has come from and where we might possibly go to in the future. Are we going to turn into robots? Are we going to go into space? But I'm interested particularly about the nature of humanity itself. Are we going to evolve ourselves? Is this the kind of thing that's going to happen? So I thought I might start by having a look at where humanity has come from and how long we've been around. And the fact is that human-like creatures who are able to use and to make and use stone tools have been around for at least 3 million years, which is a heck of a long time. And we stayed in that sort of level of being able to use stone tools, stone hand axes, things like that, for about another 1 million years. We didn't start to develop the use of fire until about 1.5 million years ago, which is a long time. And we didn't sort of develop into modern humans until about 100,000 years ago. It seems to be the sort of the estimation. So that's how we got where we are now. And it's interesting really to try and think of that timescale and put it into some sort of context and realize how small a part of that timescale we've actually had any sort of reasonable level of technology. It really is only a few thousand years. We've really had civilizations with relatively modern cities, in the sense of people living together in a bunch of dwellings and having agriculture and so on for quite a short period of time compared to that very long length of time of our evolution. And it always fascinates me that there was this big period where for about a million years we didn't really advance on the technology of the stone hand axe. That's kind of amazing. So that's how we got to where we are. Where do we go from here? Are we going from the stone hand axe to the fusion engine of our rocket ships, Chris? Is that where we're headed?
Well, yeah, it looks highly probable that we're going to go to some sort of nuclear-based energy. It's just too sweet, basically. We're getting an increasing requirement for energy, and we're finding the sources we've got at the moment are just not appropriate. They're messing up the environment and, well, causing all sorts of problems. But nuclear, it's been fumbled a little bit in some regard. Initially, when they looked at the fusion, they looked at the light water reactors, and they also looked at molten salt reactors. Now, the light water reactors were a lot easier to build, so they went for that commercially, where the molten salt ones, basically the fuel, instead of just using the top 4% of the fuel and creating some highly radioactive waste products, it just burns it all. Well, if you use the right molten salt, and the waste products will last about 100 years. So you're getting like another 94% energy and little to no waste products. So there's a lot of energy available. That's just for fission. If you want to go for fusion, well, there are a lot of things sort of occurring at the moment for fusion. I don't know how far you want to go into that, whether we want to stay on topic, but fusion is a possibility. There's people like Focus Fusion, which are having good results at the moment.
Haven't they been saying that fusion is about 30 years away for about the last 80 years or more?
Yeah, it's a bit of a joke, because they keep trying to use the big science way of cracking the problem, which is just getting bigger and bigger and bigger tech to try and crack it. I think, what is it, the National Ignition Facility, where they're just getting bigger and bigger and bigger lasers, and the lasers were achieving fusion temperatures, but they didn't have any constraint on that fusion. They weren't able to maintain it, and they weren't able to control it. It just popped, it happened, and you lost all containment. But there are technologies coming along which are quite clever, like they're using with a focus fusion, where they're using a magnetic pinch, and yes, it only happens briefly, but fusion will produce 10 times more energy than fission, and fission is already a very large source of energy. So if you can pinch it, cause a fusion, and then take out the energy from it and use some of that energy to initiate the next fusion reaction, you have a net outward energy. So it's looking pretty good. I'm looking forward to the next results. Focus fusion. It's Lawrenceville Plasma Physics. If you want to go online and look at it, their work is very interesting.
We'll put something in the show notes. I suppose it's a very interesting topic in itself. But if we're trying to look at the future of humanity, what I kind of interested in is what would the idea of limitless energy, clean energy, do to our future? What things would that open up? Patrick, do you have any thoughts about where that might apply?
Yeah, I don't see fusion in the near future, but there is a lot of advancements being made in solar panel technology. For example, the whole reason why they put solar panels on the Juno spacecraft, even though it's going all the way to Jupiter, was because of the technology in the solar panels. They were able to make them efficient enough to actually work that far away from the sun.
But wasn't that also because we're running short of plutonium or whatever it is, that the particular isotope of plutonium to put in those spacecraft? I think that's part of the reason too.
Actually, the reason, I mean, they wouldn't have been able to do the solar panel thing 10 years ago because the solar panels weren't that good. And then they've gotten new technology. So things like that, when I look at things, I'm 57 now, so and my father's 91, so I can see where we started from as far back as like almost 100 years. I can read the history books too. The first antenna was Marconi's antenna, 1920 something. Starting from there, and you can see the technology grow. We had black and white TVs, these little things, and then we had radios, and then we had color TVs, and now the color TVs are flat screen. And you see things. When I was in high school, computers were the Commodore 64, if you were lucky to have one, and now we're looking at computers in the cell phone that are more powerful than the ones that they used to operate the Apollo. I mean, you can see a movement in technology in that direction.
You're a youngster. When I was in high school, we didn't even have pocket calculators.
Right. And when I had pocket calculator, it was like $100 for a stupid little LED thing.
Yeah, I think I paid like a week's salary for my first actual pocket calculator, which would have been late 60s, I suppose. I'm 65 now. Anyway, so I mean the technology. I suppose it's very hard to get a handle on how much technology is going to affect our future, because, as you say, it's been such a rapid onset. I
don't think we're going to be taken over by robots or AI or anything like that. I think that it's going to be developed. I think more and more robotics are becoming. I mean, our spacecrafts are basically robotics. The landers and stuff on Mars and stuff, they're essentially robots. I think they're going to play an important role in our future. There are those who are implanting themselves with chips and whatnot. They think they're going to become part cybernetic. But I don't see us changing in that way as far as being less human or being taken over by AI or anything like that. That's good sci-fi, but it's not,
What about genetic modification then? I mean, how are we going to be... now that we have such biological control, I mean, that's really the kind of unseen story that isn't get mentioned a lot, is the the incredible increase in knowledge over our genetics and our physical, our biological structure. Do you have any thoughts about where that's going to go, Chris? Or can I ask?
Well, I mean, not only are we gaining knowledge about our structure from our DNA, RNA, but we're also getting a lot more power to our elbow for manipulating that as well with techniques like CRISPR. I mean, if you can use that technique to just change individual letters in DNA code, that gives you an extraordinary power to change how that basic gene line, and then it just comes down to whether those genes are expressed or not, as I understand it. So yeah, I mean, you're talking about all sorts of possibilities. Designer genes. If you want a different hair color, design a gene it. You want to be taller, no problem. It's all possibilities are opening up at the moment. But I mean, I can see there's going to be a fusion between technology and people it's going to be very blurred between where technology ends and biology begins. Especially as we get more information about DNA and the technology is just gets smaller and smaller and smaller. It's going to be shocking. Yeah.
Well, I think the genetics.
Sure.
I'm sorry.
Go ahead, Patrick.
I think the genetics is going to play a more important role in medical. We can genetically engineer, possibly in not too far a future, disease control. Genetically engineer the disease right out of you, or
I agree. I agree entirely. I mean, at the moment, we have drugs which treat the symptoms of problems, medical problems. But if you can manipulate genetics, then you can actually cure the problem rather than just treating the symptoms. It's huge, absolutely huge. It's what's called a revolutionary change rather than an evolutionary one. Yeah.
I'm not sure if they're actually practicing this or not, but I know they've been working on literally growing organs inside of pigs or animals, human organs that we can use. I'm not sure if they've actually done it already, or if I know that they're doing it. I know that but I don't think it's ever actually been used yet.
I heard that was not actually sort of pursued because if there's any problems in the blood of the animals, then as soon as you take that organ from the animal and put it into a person, you get that problem. I mean, that's how SIV, which is simian immune virus, transferred to humans. Somehow some blood products or organ or something like that, or an injection got transferred to humans. We had no resistance, and everybody got not everybody got HIV, but quite a few people, unfortunately. So I don't think that's going ahead, but you don't need animals if you can grow those same organs in people. It's you lose an organ, you can grow another one back. It's a whole load of possibilities opening up.
I suppose the ideal place to grow a new organ is inside the person for whom that organ is dedicated. So if you can use their own stem cells and somehow stimulate them to create a new heart or a new liver or something, not quite in place, perhaps somewhere in the space and abdomen, then that could be a great possibility. You talked about manipulating DNA before, but of course that would only presumably affect the children of someone whose DNA was messed about. No, that's not quite true, is it? If you can affect enough DNA inside a particular person, for example, to generate an enzyme or a protein that normally isn't being generated as part of a genetic defect, you can fix enough cells, I think, for that protein then to be generated. The thing that they talk about altering the DNA, though, I'm a programmer or an ex-programmer, and it always reminds me of the idea of here you've got this fantastically complex piece of software that you've picked up from somewhere. It does a lot of very, very complicated things. But you don't have the source code. All you've got is the object code, the assembly language instructions, if you like. And it's very, very, very hard from looking at the assembly language of a complicated program like Microsoft Word or whatever to figure out what the heck's happening at the larger scale. And so changing 1 or 2 bytes here or there in that program is going to create a disaster, usually it's going to create some sort of disaster rather than any sort of decent sort of outcome. So that's a bit of a worry to me, that you just sort of start poking here. And I know the scientists are cleverer than that, but it does seem to me that we may be overestimating our ability to understand what's going on.
Yeah, there's a lot to learn, but I tell you, I saw this documentary. It's a few years old, experimenting on a monkey. They were talking about color blindness, and there's actually this whole island somewhere. I don't know exactly where it is on the planet, but there's a whole island of people who are literally all colorblind. And they did an experiment with a monkey who's got a specific type of color blindness. So the particular species of monkey is normally colorblind. You know, it doesn't have deep color vision. It has a like 2 or 3 color type of thing. So they were doing this colorblind test on a computer, and every time he tapped the right answer, he would get some food treatment or whatever. Then they did something to his genetically, his eyes. They injected it with some kind of, like, I don't know exactly how they managed it, but they identified the code that allows to see deep color or something to that effect. And within a few days or so, they did the experiment again, and the monkey was seeing color on the screen and was getting all the right answers. The fact that he couldn't see the difference in certain colors, they were matching like different pictures of apples or whatever.
Yeah.
So that was intriguing. I mean, it's just we're talking about color vision, but and for somebody to be able to do, for scientists to be able to do that, to a monkey. I mean, they treated the monkey very well, by the way. But for them to be able to actually manipulate his vision in such a way using genetics, on a live monkey within days or weeks or whatever it took, I find that amazing. And if you could do that, you can maybe figure out other things, problems you might have, sicknesses or diseases or bad organs or whatever, and manipulate the genes right out of it.
I mean, I don't see a great deal of impetus to do genetics changes on Earth, but I'm seeing a lot of stimulus for it in space, because you go to a different environment, different gravity, different levels of sunlight. You're gonna need some changes done to your gene line to fix some problems. So it's a take it or leave it here on Earth, but in space they're going to have to do this stuff, and I think that will feed back, and they say, well, we're able to fix things. You're interested in this, and then they'll be selling us our own cures. But well, that's a little bit in the future.
Yeah, you're right. I mean, we're going to have to leave the planet sooner or later.
I want to welcome Nick Nielsen. Are you there, Nick? Nick Nielsen's joining us, I think. No, he may not be. Hopefully he's going to join us soon. Interesting enough, a long time ago, I actually wrote a science fiction story where I speculated that when people are floating around in zero gravity, then it would be extremely useful to have a prehensile tail. And we started off with prehensile tails when we were monkeys. Why shouldn't we genetically engineer ourselves so that we regrow tails? And that would be very useful to hang on to some sort of support while you've got 4 limbs. And then you'd also look at changing your feet from something which is designed very much for walking on. The human foot is a unique evolutionary adaptation, and we're terrific at walking. We can outwalk many animals. And that's how hunters in the Caligari and so on hunt down animals just simply by outwalking them. So there's something very unique about the human foot. But if you're living in a zero gravity environment, it's useless. wouldn't you be much better off with prehensile toes, the same way as you have prehensile fingers? It would be extremely useful. So you can see how, if we really get into genetic engineering and start getting involved in living in environments which are very different from the environments here on Earth, then we may well want to change things that way, as well as perhaps protecting ourselves against excess radiation and so on. So that certainly could be part of humanity.
I mean, the thing is, you start down that road and you can go the whole hog basically, because there's no reason why you couldn't adapt people genetically to actually live in space. I mean, you can survive there for about, I don't know, 90 seconds. If you can give enough protection and adaptation, you could possibly survive there for a lot longer. I mean, pearl divers, I don't know, they seem to survive underwater for like, was it 5 minutes, 10 minutes without breathing? So I don't know, there's all sorts of adaptations you could bolt on to make people actually survive in space, the vacuum of space itself, and operate there. And prehensile tails, and feet, different limbs, all possible. You can already see them. They're moving quite a ways away from baseline humanity there. It's very interesting. And do you make these germline changes so that they get inherited? Germline.
So that's kind of an interesting field of discussion, is just how humans are going to modify themselves into the future. Do you think that we're likely to get so good at medical techniques that we're going to have immortal humans? And what does that kind of mean for where we go from here? It seems to me that the people who are first likely to become immortal are going to be the people who are filthy rich. And I'm not sure that's kind of what we want. Do we want an immortal Donald Trump, for example, or an immortal, heaven forbid, Rupert Murdoch? That doesn't sound like it would be particularly useful for humanity to have people who are there, who are immortal purely by the fact that they happen to have acquired a huge amount of money through fair means or foul. What do you think, Chris?
Well, I can't talk authoritatively on Donald Trump, but
Bite your tongue.
He's an interesting character, but
let's not get into politics. I'm just looking at, if we had oligarchs or people like him, or people like Murdoch, lasting forever, is that going to be good or bad for society? He would say good, I suppose. Do you have any thoughts, Patrick?
Well, I don't think we're going to become immortal. I mean, we're constantly increasing our life expectancy, and I think it might continue if we can keep up on the new diseases that are coming up. In addition to the fact that the environment is changing, things like that. But I don't see us becoming immortal.
What do you think, Nick? Are you there now, Nick?
Can you hear me now?
Yep.
Yes.
I changed to a different connection. Well, there are a number of people in the transhumanist community who think that once you pass a certain stage, you become functionally immortal, because if you can last long enough for the technology to increase to the point where we can do whatever we want to do with it, there's no reason to for people to die unless they do so voluntarily. But of course,
which may be a choice of some people.
Yeah, I think we'd have to reckon with the fact that in a future world where it were possible for people to survive indefinitely by any of a number of different means, that not everybody would choose to do so, and that would have a strongly selective effect, whereas the only people who remain to become functionally immortal would be those who chose to hang around for it.
Yeah, it always strikes me that one of the problems with saying, like if we suddenly had a pill which made everybody immortal, there are obviously several major problems with that. One, population would explode unless we also the pill also made everybody sterile. so no more children. And then two, just think of the practicalities of it. You spend 50 years of your life perhaps working, well, maybe 40 years of your life working hard to build up enough superannuation to live off. But that's predicated usually on the fact that you're going to die by the time you're 90 or something like that. But because if you live any longer than that, you run out of money on your superannuation fund. If you suddenly gave everyone this pill that said, okay, you're going to live to 200 or 300 or whatever, how do they survive? Once, do they all keep working? How would we cope with that? It's not an issue
presumably.
Go ahead.
The wonderful story of the Kumeyan Sibyl, points to an obvious difference of possibilities, where the Kumeyan Sibyl wished for eternal life, but forgot to wish for eternal youth. So she just kept getting older and older and older until she shrunk down until she was just a voice. And of course, when people talk about eternal life, what they really mean is unending youth. And obviously, if you did keep just getting older and older and older, you couldn't continue to support yourself. So, given the possibilities of technologies like regenerative medicine, there's no reason the body couldn't be kept young on a cellular level. We may discover otherwise when we actually get to the point of attempting to apply those technologies. But there are a variety of other means at our disposal as well, and then the more abstract means of surviving as an uploaded consciousness in a supercomputer, in which case you just take a little bit of electricity and storage space, but you wouldn't have to be fed or housed or clothed, as it were.
I don't know about you, Nick, but I wouldn't want to drive in one of those things. I wouldn't want to put myself into one of those devices like that. It doesn't strike me as being a real form of immortality. It might be a simulation of you, but is it really you? But then we get into weird things about, do we believe in the soul and so on. I suppose it's tricky, but I find it hard to believe that a simulation of me, once it's turned on, would know that it was me, really. I don't know. What do you think? Chris, do you have some thoughts?
Well, it's a big divide, isn't it, basically, between machines which don't appear to express emotion and humanity that does. I mean, if you take that emotion out of people, are they really who they are? I mean, as you say, backing yourself up on a computer, is that really you, or is that just a reflection of you? So, I mean, maybe you've got some thoughts, Nick.
Patrick,
I think once again it'll be.
Go ahead, Nick. Go ahead.
I think once again it's going to be strongly selective, where the people who are interested in the sort of thing will pursue it. And if you talk about, there are so many possibilities when the technology becomes available. If you can duplicate your consciousness and store it as opposed to just transferring it to another place, then obviously you could have a population of multiple consciousnesses, which could go on to multiple different destinies, and you have a population of identities. And I'm sure people would found that profoundly morally disturbing, to think of a population of themselves in different embodiments, because once you can upload a consciousness into a machine, you could download it again into different embodiments, whether biological or mechanical, once you have the capacity. There are the possibility of endless, and the fact that people find them morally problematic is not going to stop a few people from experimenting them, especially if we have spread throughout the galaxy to the point where people can do things on the QT far away from disapproving societies.
Mm-hmm.
Personally,
Patrick, you got some thoughts here?
Yeah, I personally, I don't think, I mean, okay, maybe 1,000 years from now, I don't think it's actually possible to transfer consciousness to a computer. For one thing, if computers were become that sophisticated, a living computer, for example, biological computer, it would be a whole entity in itself. So I got this feeling that, the structure of your brain is kind of like your consciousness. It's the way your particular computer works, your brain works. If you were to transfer all your thoughts into another container, so to speak, or computer, it may reflect your personality, but I think if it was a biological computer of sorts, it may actually become its own self. In other words, it'll be somebody else.
Yes.
You know, it may think like you for a while. It may be, it may call itself your name, and it would become somebody else though, kind of like a twin brother or something.
Well, like an identical twin, actually. You think about the fact that
it would be,
it's got the same DNA.
It makes good sci-fi, because there was actually a low-budget sci-fi where these soldier robots, one of them became conscious or whatever, and they were able to transfer somebody's consciousness into a robot because he was killed. And the robot that was conscious or was sentient grabbed his companion and brought him to the factory where the robots were made, and transferred his consciousness into this robot. And like I said, it makes for good science fiction, but in practicality, I don't even think 1,000 years from now, if it were to actually be possible, I think they would become a separate entity, a separate person. Even if it was robotic, cyber.
I think what you're talking about there is basically having children, but via technological means, because you're taking yourself and saying, off you go. It's quite analogous, I think. But as I say, as soon as you have that separation, you start to get differentiation. But how close are we? I don't know, about 1,000 years. The way advances are going at the moment. I mean, it just takes, at the moment we've got advances, evolutionary advances in technology. It only takes one revolutionary advance in technology, maybe going to quantum computing or optical computing, and a whole load of possibilities open up. The world turns on that moment, basically.
Yeah, I suppose the other thing we have to think about is if you are, as you say, essentially creating a child of yourself in another computer in a computer matrix or whatever, then you have a responsibility to that child. You can't simply create a thinking entity without taking responsibility for how it may suffer or whatever. So I think that's an important consideration. We did actually have a whole episode some time ago, which was looking at these sort of moral and ethical issues to do with the moral status of a creator, which then of course gets into religious things, which let's not really quite go there, but never mind. Nick, do you have any more thoughts about this, or do you want to branch off and do a different topic? You came in late. Do you?
I'd just like to add that what we've been talking about, I think of in terms of as the speciation of personal identity. So however it goes, if identity can be duplicated or reproduced or consciousness is created, the paradigm of personal identity that we have inherited from our particular condition, the human condition of personality and personal identity associated with a single particular living human being, will be superseded by other forms of personal identity that can diverge indefinitely from that original paradigm.
Okay, where are we going from here? Do we think we were heading in a particular direction, Patrick?
I was thinking that we were going to talk about the expansion of the human race into space or to somewhere. In other words, the likelihood that this planet is not going to survive much, longer. For example, we're past due for a catastrophic impact. For example, I mean, we have to really think about the ability to leave this planet. The ability to fend off any asteroids that might be coming, and things of this nature. Because I honestly don't think we're going to be here forever. It's either go out, and explore or die, because there's only so much time. We don't really know how much time we have. But, considering the environmental changes that we caused, there's going to be some major changes anyway.
Well, we don't have firm evidence that something like that's going to happen soon, but we do have Fermi evidence, from the Fermi equation that says there should be a lot more life out there. I mean, we've got two big things which are just approaching us at the moment, which is the computer generated analog intelligence. That is going to be it is going to be a threat. There's no pussyfooting around about it. That computer intelligence, if you create something which has human intelligence and then say go and do a job, fix all junk emails so that we don't receive junk emails, that's like giving a child an M16, because it'll look at that and say, okay, well, who causes the junk emails? Humans. Let's get rid of them. Right. You have to sort of, as you say, it's the child analogy again. You once you create them, you can't just take them straight out the box and use them. You've got to give them some sort of upbringing and some reason and reasoning for what they're doing, and perhaps a moral code or something like that. So that's one big pressure. And the other big pressure is the genetics. There's so much changes on the horizon once they start tweaking genetics and having genetic cures to diseases as opposed to just treating diseases, and changes, adaptations to improve us and improve how we interface with technology. I mean, just little things. You could have a tap on your optic nerve, so you have a continual head-up display connection to the internet, and it can be done biologically. We're literally on the brink of two big things, and of course, either one of those can be a great threat to humanity. I mean, could it go wrong once they start tinkering with genes? I mean, is there any chance that it can't go wrong at some point or other? It's almost guaranteed. But then they'll have the technology to perhaps fix it.
Well, I mean, all technologies, all sciences play a role in our advancing. But like I said, I don't know what that has to do with having to leave this planet sooner or later. Sooner or later, we're going to have to leave. It could be 100 years from now, it could be 500 years from now, it could be 1,000 years. But sooner or later, we're going to have to figure out a way to get somewhere else to live.
Oh, absolutely.
We've certainly made a mess of our own planet, so we go and make a mess of somewhere else, I guess. But climate change, of course, is the really urgent issue, I think, which people are not really taking seriously enough. It's been interesting recently. There's been some studies of the planet Venus, which today is an absolute hellhole with incredible temperatures hot enough to melt lead on the surface, incredible surface pressures. And that's really all down to the fact that it got too hot. The oceans and the idea that in these recent studies, though, is that it once had oceans, and it once quite possibly had life, but for various reasons it got too hot. The oceans started to generate too much water vapor, which is a greenhouse gas. You've got a vicious circle happening. You get more temperature, more water vapor. Eventually, the atmosphere, the oceans boil off into space, and you get this incredible greenhouse effect, and the whole planet turns into just a baking hell. It's not too extreme to think that if we keep really messing up our climate the way we've done it, and we're not smart enough to fix it, then we may well go the route that Venus has gone. The other thing that's worth taking into account is the fact that the Earth. It's often said that the Earth is in the middle of the habitable zone of our star, but it's actually not. It's on the inner edge of the habitable zone
and it's getting closer to
that's right. And climate change is making it
constantly
worse.
changing.
So we may well need to move further out progressively, and Mars is the only option.
On one of the moons or something, as the sun expands. But now we're talking over 1 billion years from now. I don't know how long if we're gonna last that long. I'm sure by a couple thousand years, I'm sure we'll be out there exploring, but we still have the laws of physics to attend with. But we're going to have to go out there sooner or later, even if it's an archetype ship, that takes generations to get someplace, and then of course we have to find the right place. And the technologies now, the telescopes and everything that we have now, and the methods that we have for finding habitable planets are getting better. And I'm sure within 100 or so years, it's going to get to the point where we can actually identify habitable places. But it's a matter of getting there. You know, we have to find one close enough that, you know, that we can move to, or just live in space somehow. I'm not sure.
I think if we have the...
Go ahead, Nick.
I think if we have the resources to become a spacefaring civilization, and it can continue to develop that technology, that we can keep the Earth habitable for quite a much. Well, let me back up a bit. We can either keep the Earth habitable for quite a long time to come, on the order of millions, if not billions of years, or we can adjust our way of life so we could continue to live on Earth for quite a long period of time. I think it's worthwhile observing that human beings not only survived the last glacial maximum, but also spread throughout the entire planet and made a life for themselves in every biome on the planet, whether it means living in the Arctic or living in a desert. Human beings have been able to make a living there. Our civilization today is predicated on established infrastructure that's kept in one place, and most of them are large coastal cities that depend upon a particular level of the ocean. But we know from an enormous amount of geological evidence that not only do continents change places, but on a much shorter time scale that the ocean goes up and down depending on the amount of water locked up in ice. So I think that if human beings don't make a really big effort to go out into space, they'll at least go out into space at a scale that will allow us to adjust conditions on Earth through geoengineering, or to rebuild our cities so that they can last through higher or lower ocean levels and greater or lower temperatures. So I don't think that we can easily come to the conclusion that Earth will simply be made uninhabitable for us, because there's a lot that we could do in terms of keeping it habitable or changing our way of life so we could live here for a very long period of time.
Yeah, and
I couldn't agree more about the changing the habitability, because I mean this is essentially what Elon Musk is trying to do by introducing electric cars. It's just too easy to go on the way we've been working, just having slight evolutions of normal petrol engines, gas engines. You need to make a positive step and say, look, this isn't working. We can go to electric, and it's not going to be that difficult. But there's a certain momentum to stay where we are. That's the problem. We need some impetus to go over to a more responsible way of handling technology, like electric vehicles.
Patrick, you got any thoughts?
I agree.
We might be hit by something from outside, but it's unlikely, I think, that we wouldn't know about that in time to stop it.
What is that noise?
Yeah, what is that noise?
The thing is, we may actually get to the point where we can actually change the weather. That idea is, of course, has been explored in science fiction for a long time, including Star Trek. They have planetary environmental controls that control tornadoes, for example. And there was a Q episode on that one, because Q had killed somebody by a little tornado, and Captain Picard asked, why didn't the weather control system stop it, or something to that effect. So they've been exploring that for a long time. Now, whether or not we're going to be able to do that in the not too far future, it's hard to say. I mean, controlling the weather of an entire planet is, not easy.
on the contrary, it's very easy. We're doing it right now.
Well, yeah, uncontrolled control.
Yeah, that's right.
But it's I'm talking about literally, pressing a button or turning a knob and making a tornado go away, that kind of thing. That's going to be it may be possible in several hundred years, but I don't think we're anywhere near it right now.
Well, I'd settle just for being able to stop the greenhouse effect going wild. But
It was actually, it was actually I'm sorry, I just had a thought. There was actually somebody posted on Facebook for me a new solar cell that its byproduct is fuel, is like liquid fuel of some kind. It's a carbon fuel. It takes the carbon out of the air, carbon dioxide out of the air, and changes uses the carbon to make fuel. It's a solar cell of sorts, and it was really an amazing thing to see. I mean, this thing could actually remove the carbon dioxide from the air and use the carbon to make the liquid fuel that we need, and it's sort of killing two birds with one stone. Although I don't like to use that phrase.
I mean, are we actually going to need to do some geoengineering to fix the current climate problems, and what are the implications of that? Who would be in charge of it, for example, and who would be responsible if it went wrong? But I mean, can we imagine the idea of let's say, Chris, fusion-powered engines which are pulling carbon dioxide, holus bolus, out of the atmosphere and somehow turning it into rocks? Is that feasible, do you think? Can I throw that back to you?
Well, this is the thing about nuclear. If you have nuclear power, you have an infinite amount of power. And what can you do with an infinite amount of power? Well, anything you like, basically. I mean, we struggle with making plastics because we need oil products. You have power, you can make plastics just through chemical process and the addition of energy. This is why our world is completely going to change when we get fusion, and quite possibly even generation 4 fission. It's the horizon just gets so much further. You want to say, can we do something? I'll say yes. But the main thing is just being responsible, not using our atmosphere as a dumping ground for waste products, or the oceans. If you have energy, you don't need to do any of those things. It's just at the moment we're taking shortcuts and being a little bit lazy about how we use technology, and it's not helping us. There's people with respiratory problems because of air pollution. I mean, why do we pollute the air? I mean, we all have to breathe it. So, I think energy is going to be the big way. It's going to be the big turning point. How we actually start to address the big problems with climate change. If we can go away from conventional energy sources like oil, then we've got a chance, basically.
There's been a couple of stories, including one I wrote myself, about the idea that geoengineering may go wrong and we go too far. It's a pretty obvious idea, I suppose, and we end up with a snowball Earth. But I suppose the issue there would be is how one takes responsibility. If one particular country, in my story, it happened to be India, decided that they were going to try to fix the climate change problem, but then it went wrong. How would they be held accountable? Who would be in charge of such a thing? Would it have to be run by the United Nations? Any thoughts?
I think I just read that story.
Yeah, that's in my collection on the Cold Hill side, but it's a pretty obvious idea, really. Sorry, go ahead, Nick.
It would be extremely controversial to have any, whether national body or even an international body, governing climate engineering. I'd like to go back and mention that I think Chris is really correct that we've been adopting short-term solutions and not taking responsibility. But in the really big picture, the age of fossil fuels is only going to be a few hundred years. If you think that agricultural civilization lasted for about 10,000 years before the Industrial Revolution happened, the industrialized society based on fossil fuels that we have today isn't really going to last all that long. The fossil fuels will be used up, or we'll get better alternatives within the next few hundred years. and we can do something very different. But I would like to mention a form of potential climate control that is not mentioned very widely, but it's very straightforward, and that is what are called Dyson dots, which are shades put between the Earth and the Sun in order to cool it by a few percent. And the great thing about Dyson dots is they're reversible. You can take them away, you can make them smaller, you can make the shade less, and if you go too far, if you make the Earth too cool, you could put mirrors up and focus more solar energy on the sun and increase the insolation. So just by having the relatively rudimentary spacefaring presence of being able to conduct engineering projects in Earth orbit or farther out, say at the Lagrangian points, there are quite considerable things we can do in terms of keeping the Earth habitable without getting it too hot or too cold or too wet or too dry. And these are all entirely reversible projects.
Mm-hmm. Sounds good. All right. Are we all done here, do you think, or are we have more to talk about the future of humanity? Do we have any bids for further topics, or will we wind up?
Well, when we talk about the future of humanity, we're only talking out about a few million years, because in human beings whether by artificial or natural means, human beings will speciate. And if you came back to the Earth in 500 million years, which is 2 orders of magnitude beyond the length of our branch of primates, things are going to be very different. And that's, in cosmological terms, not that far out. So however you want to extend, the possibilities of the legacy of human beings and human civilization in the future, you're going to be contending with very, very different environments. The environments of the future Earth, after the Earth is no longer habitable, but other places in the galaxy are. Then once all the stars burn out and the stelliferous era is over, but there's still sources like degenerate suns, fragment, the end stages of stars and black holes, etc. So there's always ample room to talk about more distant future possibilities.
It's certainly interesting to speculate on, isn't it? How we could stay alive even once the stars are dead. It's I'm not personally very optimistic that we're going to last that long.
So, I think it's a little far-reaching to talk more than a million years. I mean, we've evolved in a matter of a few 100,000 years to an extent. A couple million years ago, we weren't even human, but our ancestors were on the way up to being us. But so if you're going to look into any amount of time that far off, I would say on an evolutionary scale, I'm pretty sure we're going to be I'm pretty sure we're going to have evolved, say about 5,000, 10,000 years from now. If you were to compare us now to 10,000 years from now, humans 10,000 years from now, I think there would be an evolutionary difference, and then another 10,000 on top of that, and so on. If you go up to a million years, we may be as different to us as we are to our ancestors a million years ago. The hairy creatures that were, Artie and all them, the Australopithecus and all that. We may be as different then to us now as we are to the Austros. So,
but that time scale really assumes natural evolution, and I think from now on, it's much more likely that we'll be developing an artificially evolved human being.
Forced evolution, almost. I mean, you almost say there's going to be speciation by 100 years from now, because Elon Musk, SpaceX, they're talking about going to Mars in 10 years. You go to another planet, you create another species, because the environment is so different there to what it is here. Gravity, air pressure, radiation. I mean, we've been relatively stable because we have relatively stable conditions on Earth. But you put us in a completely different condition. All sorts of things will turn up from our junk DNA to adapt to different environments, and straight away you have speciation. Taller people, we don't know what the heck's going to happen when we arrive there.
You're going to get genetic changes on a short time scale. First few generations are going to start changing.
It all depends how quickly we get out there, though. I mean, if Elon Musk has a heart attack and all this goes away, and we leave it up to NASA, and they say mañana, 2040, 2050, we've got to have a star drive to get to Mars. Yeah, it could take a great deal more time. But if they decide they've got the technologies to do it now, they can do it with plain old-fashioned rockets, refueling them in orbit so they can get a bit more payload there and setting up a colony there, a regular service. There's no reason why you can't do it in 10 or 20 years, but it all comes down to the technology.
And I also think they have to watch out with the radiation, too.
Oh, yeah. Well, actually, there was some stuff coming out of that during the week. Did you see that the NASA astronauts that went to the moon, the Apollo astronauts, were suffering from sort of heart failure? I think it was like 3 out of 7 died from heart failure. And there was a discussion on the Reddit that, that's too small a sample group to say there's a problem. But we delved a little bit more deeply into it, and it seems that this is a well-known phenomenon in medicine, that if you radiate the whole body, the veins thicken, and so it's more stress on the heart to drive the blood through those veins. And of course, the veins also supply the heart, and the heart. So the heart has a double whammy. It has to work harder, and the blood being supplied to it is less because the veins are thickened to supply the heart. So yeah, there's a problem with radiation, but there's various things you can do about that. Perhaps one of the best approach is have a magnetic shielding on the vessel, so you actually deflect some of those really hard radiation.
I suggested that to Pamela Gay when she was on with us with Paul Carr, and she was pretty firm that it would take a hugely strong magnetic field.
I wouldn't say hugely. Well, you can have a reasonable magnetic field using superconductors, because of course, in space you're close to absolute zero temperature, so superconductors shouldn't be a problem. But I mean, in space, that field it'll extend. How far will a field extend in a vacuum? Quite a way. There's nothing to stop it. So I don't see technically there's a problem. I mean,
I agree with you, but Pamela Gay, being the astrophysicist she is, and she was pretty firm that it would take too much power, or I don't know. To me, any magnetic field, even a weak one, would be better than no magnetic field. But
absolutely.
These particles can go right through a weak magnetic field, so I don't know.
Well, I mean, some of the big nasties in the galactic radiation is nuclei of iron. They're moving at relativistic speeds. I mean, they'll go through your DNA like a wrecking ball, basically. But iron it's ionized as it's a nuclei, and it's inherently magnetic. So you impinge that on a magnetic field, and you've got two effects straight away that's going to start deflecting it. So
who knows?
Yeah,
there's no reason you couldn't put There's no reason you couldn't put a nice, strong nuclear fission reactor on board a Mars ship and have a nice, strong magnetic field.
That's what I was thinking. That's what I was thinking. I agree with both of these. I mean, but like I said, who might argue with an astrophysicist?
When I was at the 2012 100-year Starship, I talked to a guy who was working on magnetic field protection for astronauts for longer missions. I don't remember his name or the name of his project, but there are people out there working on this problem.
Right. I mean, going to the moon is not as dangerous as going to Mars. Even, believe it or not, even as far out as the moon, you have some, not a lot, but some protection in the Earth-Moon system. But as soon as you get out of the the effects of the magnetic fields of the Earth system, you're in a lot more danger, on your way to Mars. And then Mars doesn't have any magnetic field to speak of as it is, so you'll be in danger all constant from there. Not just solar radiation, but the cosmic rays.
It would be good if we could develop a really efficient way of protecting ourselves against radiation, and that really would open up the solar system. Think of the moons of Jupiter, for example, which would be impossible for humans to visit at the moment because it's I'm not sure what the right term is, but its ionosphere or the magnetic field, the equivalent of its Van Allen belts, bring a huge amount of radiation to the surface of the major moons of Jupiter. So even though they're very interesting places, and a place like Europa and so on, it would be impossible for us to establish a colony or whatever there, even though it would be interesting in other ways, unless we could fix that protection problem.
I just wondered how much radiation actually gets down to the surface of the moons. Do they have their own magnetospheres? As if they do, you only have to solve the problem how to get there, cross those, radiation belts. Yeah.
Yeah, I don't think they do.
Jupiter's magnetic field is so powerful that it literally reaches to the orbit of Saturn. That's how powerful. Yeah, it's a very extremely powerful magnetic field.
All right. I'm starting to think about winding us up. I know it's only been an hour, but I'm sort of flagging. Anyone have any further thoughts we should investigate before we go? Oh, you happy?
Just to mention briefly that if we can build a nuclear-powered radiation shield for a spaceship, we can build a nuclear-powered radiation shield for a settlement on Mars or another place. But obviously, it's a much once you get into a magnetic field as powerful as Jupiter's, obviously you're talking about some later generations of technology that can handle those bigger loads. But if we can do it for a spaceship on the way to Mars, I don't see why we couldn't do it actually on the surface of Mars.
Mm-hmm. Yeah.
Okay.
Yeah.
Once we get used to the idea of using the fission nuclear technology that we have. We know that people are very uncomfortable with that, but it's a technology that we have now, and we mastered it, and we can produce a lot of electricity in a relatively small space.
Well, as Chris says, it's all about energy, isn't it? If we can master energy, then the galaxy is our oyster, as it were. Never understood that phrase actually, but anyway.
You don't actually need an awful lot of energy, though, to use superconductors. As in, if you have a superconductor magnet, all you're feeding is the losses, the resistance, and the resistance are very low as you approach, zero, absolute zero. So, yeah, I agree with you, though. If you can have like a Gen 4 fission reactor, you can do anything. You can get to Mars in 30 days. You can take zero radiation exposure. It's all about the energy at the end of the day. I'm going very space opera now.
Well, why not? Indeed. Okay. All right. Well, look, I think we've had a very interesting discussion, and I think I might wind it up there, if that's all right. So thank you very much for being part of this broadcast. I hope it's gone well. I hope this thing has been recording. I've got no idea. This is the first time I've done it. We've had a very interesting discussion. So thank you to Chris Prophet, Nick Nielsen, Patrick Festa, and myself, David Grigg. This is the episode 57 of the Unseen Podcast. Thank you for Paul Carr for trusting me with it. I hope I've done it right. And thank you, and we'll see you next time. Okay, bye.
Thank you.
All right.